Okay, so I'm going to be going over the circle test review. So starting with number 1, it's asking what is the degree of angle C. So what this has to do with is the theorem that describes opposite angles inscribed in a quadrilateral. And it says that the measure of angle X plus the measure of angle Y is equal to 180. So basically, opposite angles in a cyclic quadrilateral are supplementary. So what that means for us is that we can solve this equation by saying 10A plus 20A is equal to 180. So in other words, 30A equals 180. Divide by 30. We get A is equal to 60. 6. Okay. Okay. So then after we get A, so remember this is not your final answer because it's asking what is the degree of angle C. So you need to plug 6 back in here. So 20 times 6 is equal to 120. And that's our degree for angle C. Okay. All right, number 2. What is the area of the shaded region? So the formula for area of a sector, and you've got it on your chart, sector area. Now they write it like this, the measure of arc AB over 360 times pi r squared. This formula works. I prefer the formula that's just written as theta pi r squared over 360. Keep in mind in this situation, theta just represents your central angle, and your central angle and the measure of this arc are the exact same thing. So just replace theta there, and you've got the same formula. All right, so theta pi r squared over 360. In this problem, our angle is 90, and our radius is 4. So 90 pi, 4 squared over 360 is equal to times pi, 360. Okay, so we get 12.57. And then for the other one, the only difference is the radius is 3. So 90 pi 3 squared over 360 equals 7.07. Add those together because we want both areas. So 12.57 plus 7.07 is equal to 19.64. Okay. What would the equation of a circle be if the radius is 5 and the center is at 2, 2? You also have equation of a circle as the last formula on your formula chart. So equation is written in the format x minus h squared plus y minus k squared equals r squared. HK represents your center coordinate and r represents your radius. So in this case, it's going to be written as x minus 2 squared plus y minus 2 squared, and then 5 squared is 25. Okay, so that's how we would write it. All right, what is the degree of angle BAC? BAC is an inscribed angle, and the reason that I know this is because the vertex of the angle is touching the edge of the circle. That's what it takes to be an inscribed angle. Now, what we know about inscribed angles, it's the first theorem on your chart, is that inscribed angles are half the measure of the arc. So this is half of this. Okay. Now, I know here we're given the central angle, but central angles and arcs are the same. Okay, so this is also 110. So all we need to do is 110 divided by 2, which is equal to 55. Next, If a triangle is inscribed in a circle and the hypotenuse is the diameter, what type of triangle is it? This is the second theorem on your formula chart. It says angles inscribed in a semicircle will always equal 90 degrees. So if you've never thought about why, so this is an inscribed angle, right? We know inscribed angles are always half of the arc they intersect. Well, if this is the diameter, then this arc is 180. 180 divided by 2 is just 90. And that's why this angle will always be 90. And that's what this question is asking. If we have a triangle and the hypotenuse is the diameter of the triangle, it's going to be a right triangle. Kind of a key word there that they use the word hypotenuse, because you don't have a hypotenuse if it's not a right triangle. Are there any congruent angles in this picture and why? This is relating to the same theorem. This is an inscribed angle. It connects to the diameter of the circle, which means that this angle would be 90 degrees. On the other side, angle N, same story. Inscribed angle connects to the diameter, so it's going to be 90. So K would be congruent to N because they're both 90 degrees. Number 7. What are the two missing arc degrees of circle M? So key piece of information here is that this line ER, we can see it passes through the center of the circle, so this is our diameter, which means this half of the circle would be 180, and so will this half of the circle. So to get this, 180 minus 60 is 120. And then over here, we need to add up 70 plus 40 first. So that would be equal to 110. 180 minus 110 leaves us with 70. Next, find the missing arc degrees. Okay, another key point here is that this is the diameter since it passes through the center. One thing I see right now is that this central angle is 90. Central angles are the same as the arc, so that will also be 90. That if this is 90 and this is 180, then that means this is also going to be 90, since 90 and 90 make 180. So then 90 minus 30 gives you that this piece right here should be 60. Okay, this is an inscribed angle, that 40 degree. So we multiply that by 2 to get the arc, so this arc would be 80. And then this is half a circle from R to C. So 180 minus 80 leaves us that this piece would be 100. If a radius in a circle touches a tangent line to the same circle, what happens? So this is referring to this theorem, radius and tangent line. When the radius of a circle touches a tangent line of that circle, they are perpendicular. And this is what the picture looks like. So we can create that same picture. Here we've got a circle. There's our radius. Here's a tangent line. Those make a 90-degree angle. I also just want to note that this 90-degree angle does go outside of the circle. Okay, so it's not a 90-degree angle in the circle. It's from this line to this line, and since tangents are outside of the circle, this 90-degree goes partially outside. Okay. Below there is an isosceles triangle with two legs tangent to a circle. What is the degree of angle X? So keywords here These are tangent lines. And this is an outside angle that we have that's being made with these tangent lines. This goes with the theorem. So if we look at Theorem 5, okay, Theorem 5 has two parts. If you're forming an angle inside of the circle with two secant lines, then the formula is 1/2 x plus y. If you're forming an angle outside of the circle with either a secant or a tangent, then you're subtracting x minus y. And then you need to look at what x and y represent in these pictures. So they represent the two arcs that are in between those lines. So here we have two secants. X is the larger one, y is the smaller one, and they're in between the two lines. Here we have a tangent and a secant. Here's our larger arc. Y is our smaller one, and those are in between. Here we have two tangent lines. Okay. So these two tangent lines, these arcs are going to make up the whole circle. X is the major arc, and then Y is the minor arc. Okay. And we subtract those and divide by 2 to get this outside angle. All right, if you look at our picture is using two tangent lines like in this picture. So what we're going to have to do, first we need to get this arc here. Okay. So we can get that arc by doing 360 minus 120. Okay. That gives us 240. Okay. All right, so then our formula says that x is equal to 1/2 of 240 minus 120. 240 minus 120 divided by 2 leaves us with 60. You want to see that on the calculator. Okay. What is the sector area, which has the arc of PJ? And what is the arc length? So it's asking for the sector area and arc length for this section. So just follow the formula. You do have these formulas on your chart, arc length and sector area. Now, again, I prefer this formula. I just think it looks nicer, but it's the same thing. If I wanted to put my theta formula for arc length, theta just represents this angle, which is the same as this arc. So all it is theta pi r over 180. Now you might notice that this one is over 360. So the reason for that is because if you put this all together, so measure of AB times 2 pi r over 360. And then all I do is I replace that with theta, the theta symbol. But the thing is, this 2 and this 360, you can reduce. 2 over 360 reduces to 1 over 180. So really, this formula could be written as measure of AB pi r over 180, if you want a more concise formula. Okay? But either way, you get the same answer. Doesn't really matter. All right, so I'm going to use my preferred formula, theta pi r squared over 360. So we've got 100 pi 7 squared over 360. So that's equal to 42.76 arc length. Again, I'm going to use my preferred formula. Other one, it works the same way though. So 100 pi times 7 over 180. And that gives us, oh, hold on, I did that wrong. Okay, let's put this 100 by 7 over 180. So that gives us 12.22. Okay. All right, I'm going to stop this video so that it doesn't get too long. And if you want to see the back side, then click to the next video.